Hi guys, I'm Mr. Joseph, your chemistry teacher. I'm back with my lectures. So in today's lectures, we'll be considering electronegativity. Our lesson objectives for today's class, we'll be talking about what is electronegativity, how we can measure electronegativity, that is measurement of electronegativity. Then we'll also discuss trends in electronegativity and polarity in molecules, how we can use the electronegativity value to predict whether a bond is polar or non-polar, and also identify molecules that have polar bond and non-polar bond. So I want us to listen attentively. It's as simple as ABC. Listen attentively and get the best out of today's lecture. So from our previous lecture, we've covered bonding. I believe we must have done bonding. And we're looking at covalent bonding. In covalent bonding, we did covalent bonding. In covalent bonding, it involved the sharing of electrons between two or more non-metals. It has to do with sharing of electrons between non-metals. You know, I told you that the essence of bonding is for each of the atoms to attain its noble gas configuration. So in covalent bonding, a pair of electrons is shared between two or more non-metals. Now, what happened in electronegativity? This is the ability of an atom to attract a shared pair of electrons to itself in a covalent bond. During covalent bonding, each of the atoms contributes its own electron for the bond formation. So electronegativity is the ability of an atom to attract the shared pair of electrons to itself in a covalent bond. So what happens? The more electronegative element draws the pair of electrons to itself in a covalent bond. So while the less electronegative element, it becomes electron deficient. So the greater the electronegativity value, the greater the power of an atom to attract the electrons in a covalent bond towards itself. So electronegativity is just the ability of an atom to attract electron to itself in a covalent bond. So measurement, when we talk about measurement of electronegativity, we use a Pauling scale, which is a scale for measuring electronegativity. So electronegativity of atoms of elements can be measured using a Pauling scale. Now, based on the Pauling scale, electronegativity value increases as you go across the period, and the value decreases as you go down the group. So if you look at the periodic table, it is clear that fluorine has the highest value in terms of electronegativity. So fluorine is the most electronegative element. So as you go across the period, increase across the period and decreases what? Down the group. So we're going to look at the table of what? Electronegativity values of elements. So this is a Pauling scale, which is a table that shows the electronegativity of elements. So from the table, you can discover that the electronegativity increases as you go across the period and it decreases as you go down the group. So fluorine is the element that have the highest electronegativity. Now, with the help of electronegativity values, we can tell if a bond is polar or if a bond is non-polar. We can identify molecules that are polar and non-polar molecules. So as we proceed, we'll be making reference to the table. We'll be getting the electronegativity values of one or two atoms to predict the polarity of a particular bond or a particular molecule. You can tell if a molecule is polar or non-polar. So it's as simple as A, B, C. So we're looking at polarity in molecules. So with the help of electronegativity values, we can determine the polarity of a particular molecule. When the electronegativity values of the two atoms forming a covalent bond are the same, so the pair of electron is equally shared. So we say that the covalent bond is non-polar. So when the two atoms have the same electronegativity difference or similar electronegativity difference, the covalent bond is said to be non-polar. For example, we have hydrogen, single bond hydrogen. What happens is that each of the atom, this single bond is an indication that each of the atom contributes one electron for the bond formation. So the pair of electrons are equally shared. Now, if you look at the electronegativity difference, hydrogen, the electronegativity value for hydrogen is 2.1, and the electronegativity values for hydrogen is 2.1. So 2.1 minus 2.1 is equal to what? 0. So if the electronegativity difference is within the range of 0 to 0.4, we say the bond is said to be what? Non-polar. The covalent bond is said to be non-polar. If you look at chlorine, this is Cl single bond Cl. One chlorine atom, the electronegative value is 3.0, The other chlorine atom is 0, 3.0. 3.0 minus 0.0 is what? 0. So the covalent bond is a non-polar covalent bond. If you look at bromine molecule, the same, they have the same electronegativity difference. So it will all sum up to 0. So the covalent bond is a non-polar covalent bond. Let's take carbon single bond hydrogen. The electronegativity from carbon is 2.5 and hydrogen is 2.1. So 2.5 and hydrogen is, this is 2.5 and hydrogen is 2.1. So if I had to check, the difference is 0.4. So the bond is said to be what? Non-polar bond. So it's as simple as A, B, C. So still on polarity in molecules, we just consider non-polar covalent bonds. So we want to look at polar covalent bond. When a covalent bond is formed between two atoms having different electronegativity values, that means one is more electronegative than the other. So the more electronegative atom attracts the pair of electrons in the bond towards itself. So the more electronegative atom with the partial charge, delta negative, while the less electronegative atom with the partial charge, delta positive. So we say that the bond is polar, or that it has a dipole. And when we talk about a dipole is a partially positive and a partially negative charge that is formed as a result of electronegativity difference between two atoms. That means the center of positive and negative charges do not coincide, and the electron distribution is asymmetric. That means the electrons are unequally shared, the electrons are unequally distributed. So let's take an example. We have carbon single bond fluorine. The single bond is an indication that each of the atoms contributes one electron for the bond formation. Now, if we look at the electronegativity table, you discover that fluorine is more electronegative than carbon. Fluorine has electronegativity value of 4.0, while carbon have electronegativity value of 2.5. 2.5. So fluorine is more electronegative than carbon. So fluorine will be partially negative and carbon will be partially positive. So that means this bond is a polar bond because it has a dipole. In fact, how do you identify a polar bond? You look at the electronegativity difference between the two atoms. If the electronegativity difference is within the range of 0.5 to 1.5, such a bond is, to 1.9 or 1.5, 0.5 to 1.9. Such a bond is said to be a polar bond. So it is polar. So if you look at the electronegativity difference here, 4.0 minus 2.5 is 1.5. So the carbon fluorine bond is a polar bond. Let's take another one, carbon single bond oxygen. If you look at the electronegativity table, oxygen has electronegativity difference of 3.5 and carbon has electronegativity difference of 2.5. That means oxygen is more electronegative than carbon. So oxygen will be partially negative and carbon will be partially positive. So if you look at the electronegativity difference is 0.5. So we say the bond is polar because it has a dipole, which is a partially positive and a partially negative charge that is formed as a result of electronegativity difference between the two atoms. So that means the electron distribution is asymmetric. The electrons are not equally shared. So before us are typical exam style questions. You have to predict the polarity in the following bonds. Where applicable, you draw in the delta positive and delta negative charge. So just to determine the polarity. So please attempt these questions. They are very, very simple. So just listen to the video attentively and attempt the question. So you are just to predict the polarity. With anyone that is polar, you put the delta positive and the delta negative. If it is non-polar, that means it doesn't contain the delta positive and the delta negative, which is doesn't contain a dipole. So it's as simple as A, B, C. Attempt the questions. Feel free to reach out to me if you encounter any difficulty. I'm always there for you. I'm there to help you. So please attempt these questions and reach out to me if you encounter any difficulty. Thank you very much. Mr. Joe, your chemistry teacher. So please subscribe to my YouTube channel, like, comment, and reach out to me if you encounter any difficulty while watching the video, or if you don't understand the concept. Please feel free to reach out to me. I'm Mr. Joe, your chemistry teacher. I'm always there for you. I'm always there to help. So feel free to reach out to me. So go to the comment section, you comment, like the video, and share with your friends. Thank you very much. Mr. Joe, your chemistry teacher.